So this will constitute with Tim presenting on blockchain and then everyone answering questions that you might have about data tracking. So Tim, please go ahead.
Can you hear me okay? Okay. Hi, everyone. My name is Tim Guo. I'm from Yale BITS. And then today it's my honor to quickly present our work related to blockchain for Bridge2AI. And then this is our team. And then it's our honor to also have two NIH officers, Dr. Sen and Meiji, to join us to do a quick demo. So, and then also our team member Lana will be helping with this. So let me get started. So basically, what we plan to do is to track the data release of Bridge2AI, including understanding who submitted data, so that we can verify the source of the data, confirm the ownership of the data, and then also on the other hand, we want to understand who requests and access the data, because then we can credit the data creator and also analyze the use of the data, the impact of the data, etc. So intuitively, we can set up a database. This is not a new concept. So we can allow people to submit the data and then allow a requester to request the data. But then the issue for this conventional setup is that this creates a single point of failure, because if the central repository is under attack, then things can be not reproducible anymore, because the record can be changed. And then also, it is not transparent or source verifiable, because only the root user of the central server can see everything. All the data submitter and requester cannot. So ideally, we want to decentralize this design. So one way to do this is to use technology called blockchain. So this is an underlying technology behind Bitcoin, Ethereum, and many other cryptocurrencies. But of course, we are not using it for financial purposes, but instead we use this as a new decentralized data ledger. So basically, in this chain of blocks, for each block, we store these submission transactions and then requesting access transactions. So record these transactions on the chain instead of using a centralized server. So as we can see, submitter can submit from any of these blockchain node or computers, and a requester can also request from various nodes. So this brings some benefits. For example, it is more reproducible, because all of the submission and request transactions are recorded immutably. And then also it is more transparent, because then the party can see who access the data and then can verify it. So here, one thing to notice is that we only store the transactions of the data on the blockchain, but not the data themselves. So, I will then switch to the demo today. So, and by first introduce what it looks like. We use this Mimic 4 demo version of the data, which contains 100 de-identified patient data. So it is publicly available, no DUA required. And then in this demo, we split it into two parts just to showcase it. So one with 44 and one with 45 number of patients. And then also we extracted 44 covariates from the data set. So this is just a snapshot of the data. And then also for the metadata part, it's very simple. In this demo, we just show that we kind of categorize these 44 covariates into 3 tiers. They have different access capabilities. So the first tier being most least restrictive, and the third tier 3, being most restrictive, like patient ID. And then in our demo, basically the metadata for these two split data sets are the same. But then of course, this is how it looks like. And then in the real world, of course, different data sets can have different metadata. And then in our demo, we will create 4 user accounts. And then as you will see very soon, 1 submitter and then 3 requesters. So these requesters, they all have different level of access right. So as you can see, tier 3 user can access everything, but then tier 1 can only access tier 1 covariates. But of course, in practice, different, so this access right can be different per data set per user. So for our workflow today, the submitter, who will be our NIH officer, Meiji, will be submitting the data and the metadata to the blockchain, and then also do it once again for the second data set and metadata pair. And then our requester Dr. Sen will serve as 3 roles, like a requester 1, tier 1, and then select some covariates, and then access the data, and then do the same thing for tier 2 and tier 3. So without further ado, let's start the demo. All right, so as you can see now, on the left-hand side is our graphical user interface, and then the right-hand side is the blockchain running. So you can see, I know it's a bit small, but you can see the blocks keep creating, and then the 2 nodes are like a sync, so the block number are the same. Yeah, so we will probably stop this running by disable the message a bit so that we can see things more clearly. All right. And then on the other hand, let's start by having Magic help us submit the data. So basically, we first log in. Yeah, and then we can see that after logging, we will see the affiliation and access tier, and then we can start submitting the data set. And then here we can choose the metadata to upload. So we choose this tier 1.csv, which is the metadata. The content is exactly as the one I just showed, basically just a tier information. And then also the data set itself. All right, and then we can submit it. All right, so as you can see, once we submit on the right-hand side, we see that the upper one now shows like a message about the submitted data set and its accompanied metadata. And then as you can see, the bottom one also sync now, so that they are showing the same thing because these 2 blockchains, they are like connected. Okay, so we can continue to submit another record, please. So now we choose this tier 2 metadata and also the tier 2 data set. Not tier 2, but the second data set. All right, and then we can again submit them. Okay. So now we are done with the submission. So now we have 2 data set and metadata pairs stored on the blockchain, and then we will start with the requester. So we have Dr. Sen helping us do this. So now we start from requester 1, who only have tier 1 access right. Okay, and then now we can see access tier 1, and then we can request data set. So now we have 2 data set that we can choose from. So yeah, so please choose anyone. Yeah, so once we click, we can see that it show up the only the tier 1 covariates to allow user to choose from. So now please choose some of the data, the fields. Yeah, and then we just go next. Oops. So, okay. So, yeah, so we see that once requested on the right-hand side, we'll also see the request information being synced. And then now this is the data preview of the 2 covariates selected. And if we click that access, then we'll actually download that CSV. Maybe we can click that CSV to show. Yeah, so we see that in this CSV file, we have 2 covariates and then the data. So it's like based on the users, the requesters, like a selection, we can get this. So so now maybe let's try another requester, kind of like a tier. Yes, please try. All right, so again, this is access tier 2, as we can see, and then we can now request the data set. And then again, please choose one of them. And then now we can see more covariates here because now it can access both tier 1 and tier 2 covariates. So maybe we can next. And then here's a preview, and then we can again access the data. So yeah, so this is the second tier. And then finally, we will try this third tier, which can see everything. All right, so this is tier 3, and then again, we request the data, choose one of them. And then this time, Dr. Sen, maybe let's try select all and then see, yeah, we can then, so we can show the whole thing. All right, and then let's click next, access, yes, please. All right, so this is actually the, oops. Okay, so this is actually the whole data set because we select all. Okay, so thank you so much for helping. And this is basically our quick demo. So now I'll use the rest 1 minute to go over the rest of the slides. All right, so basically, in this demo, we can see that user can only see and operate the front-end GUI, so really don't need to have blockchain knowledge to do all this. And then also, the system can be wrapped in Docker or API so that the system admin or the software developer who use this don't really need to have decent blockchain knowledge as well. Oh, should go. And then also this can protect patients' privacy because the data set, I mean, in our demo, of course, we just show that that's the CSV file, but in the real world, it should be downloaded into an enclave so that the data privacy can be protected. And then the hardware requirement, as you can see here, is rather low. So the cost is also not very high to run this blockchain-based solution. And then we estimate the data submission and access speed to be around like 2,000 transactions per day at most. But then currently our capacity is about 40,000 transactions per day. So it's 20 times better than the estimated request number. So for the next step, we plan to develop this auditing dashboard so that the access log can be encrypted and then can only be seen by either the data submitter to see who accessed their data or the founder, which is NIH. And then on the other hand, another possible improvement is to add a search box in that interface so that people can get their covariates quicker. So the take-home message for today's demo is that it is feasible to track data submission and access using blockchain. And then the user might feel like this is the same, the system, if not looking at the background kind of those terminals, I feel like this is the same as the traditional database like application. But really, we are using blockchain to provide these additional benefits of decentralization and immutability and transparency. So maybe I will stop here. Thank you.
Thank you, Tim. It was brave to do a demo, and I saw you put an error message just to be more realistic. So, well, as you saw, is a database, right? There's no mystery about it. It's a decentralized database. So if someone wants to pretend they had multiple downloads, you can see that they did or they didn't, right? If you were authorized. The other thing is a very green protocol, because since we're dealing with a private network and not the, the whole, so it would be the 4 DGPs, for example. Then you don't need to do those very computationally expensive mining protocols to get Bitcoin, get money, and so on. It's much simpler. So what we had proposed was to do that or experimentally for the transactions that happen so that you can track over time, not only in this case who got it access to the data, but which elements they got and things like that. So it's simple. I mean, blockchain is not a new concept. It just takes some time to be adopted. And as the DGPs have been so focused on the production of the data, now that the data are out there, maybe it is the time to go about all of this. So we invited folks to be our demonstrators, but also comment on the tracking of data, how important that is or how unimportant that is. Satra under protest is there. Thank you for. And then Joe also got ahead of it because he does have a working system based on blockchain that deals with the particular data sets that he has the responsibility for. So I think as opposed to the other panels where I ask a leading question, I would just say ask questions from the audience to see if you have any question, comment, addition to what we're doing. And it's very short period of time, right? We have one year left to get this going. And the overhead on the DGPs is minimal because of the Docker and because of how we want this to go. So Aaron.
Yeah, really great work and really exciting to see the tech demo. I was curious, how does this fit in with some of the problems that Mike Chang raised yesterday, or I guess that was 2 days ago now, when he was talking about attribution and trying to encourage metrics of sharing rather than the traditional, H index that is usually thought of. So I'd love to hear your perspective on like how this system might be able to address some of those issues that were raised.
Right. So, and Tim might have even that slide. What we presented before to the group, the working group, was that there must be a system that not only you get credit when the data are shared, but when someone builds a model on top of that data and that model was used, so the original perhaps gets fewer points, but it gets points rather than the last thing that was used, because that tool wouldn't have existed without that particular data set. So tracking is not only data, is byproducts of the data, pre-processing tools with that data, or process data sets that someone else built, right? So we have a faculty member who wants to do de novo assembly from all reads, right? Lots of work, and then want to put that data set available. If someone uses that data set, he should get credit, but the original folks who got the reads in the first place should get partial credit or some system like that. So I think that's the picture here. So I'll just go quickly. So you are the DGP, you are G1, right? You're also G2 because you create an AI-ready data set, and then you do a predictive model on top of it and generate results. So think anyone could use any of those squares there. Let's say G3, another group, uses your predictive model on their own data and generates a new result and so on. So like I was saying, maybe G2 gets half point and G1 gets 20.25 because it's 1 degree removed from what was used. And then you see G4, which is the reproducibility person or a group who would say, well, I'll use exactly this model, exactly this data set and see if I get the exact same thing. And then let's say they produce a paper, they should credit backwards G3, and also it gets credit to G2 and G1. Again, what those points would be, how would that, whether they translate into money, which would be good. is something I think it's more on the, you know, have to be a group consensus, have to be NIH saying what is reasonable to count as credit, because you know, we are tired of moral victories, right? We want the actual thing to make some sense. So I think what Michael Chang was saying right in the beginning of this meeting is that they're very interested in seeing, you know, way beyond the H index, how there could be a system that academics would also make use in promotions and appointments and things like that. I think that that's another degree removed, but if at least we can get ourselves to credit more the people who not only generate, but also transform, curate, and again, all along this path, and there could be multiple different paths. I think we are in good shape towards making innovations that the Bridge2AI consortium is supposed to be generating. So I think that's one thing that the novelty is not in the blockchain. It is on how we use it to enable all this credit attribution. Microphone? You can use here.
So Tim and Lucilla, thank you for this. And clearly this is a very powerful tool. And there are other programs such as the BRAIN Initiative that's really recognized that time stamping is really critical to protect and be trustworthy on the data that's created, right? And so I have a couple of questions on how does this compare with perhaps less compute intensive tools for time stamping? And have you done a comparison? And you mentioned that this is not compute intensive now, but how would it scale if you imagine thousands of people using Bridge2AI data? How would that work in terms of the computational cost?
I would say it's minimal. I would continue to say it is, because I mean, we're not Bitcoin, right? Anywhere in the world, people, it's a totally different thing. It's a very constrained set of users, right? So I would say even with all of us, if they were to, they have already several thousand users and so on. I don't think, and Tim has those experiments where you measure thing, communications and everything. So I think it's totally scalable to the research community.
And comparing it with less compute intensive methods now?
So like I was saying, proof of work is one protocol that consumes farms of computers somewhere because it's made to be difficult. So not everyone gets the money of the reward of mining a block in the blockchain. But in our case, we are not competing. We're just distributing who builds the block so that no one is overloaded with the work. But the computational part is very simple, and Tim has options. You know, there are several protocols alternative to proof of work at this point. So it's a green blockchain.
Hi, as you know, like one of our goals is to work with other partners and so on. In this case, what will take for the partnering side to do in terms of implementation to be able to use this technology together with the Bridge2AI data sets?
So again, as more of a social phenomenon that is a technical one, any partner would have the technical ability to do this because it's very simple technology in the end. What is more is like in that the DGPs were worried about how much of data entry there is, how much, you know, you can automate whatever. They already have their portals and everything. So I think to get other programs to contribute is exactly, you know, showing that there is not that much overhead. It doesn't distract people from their primary functions. But just like we were talking with the All of Us program yesterday, I think it would be very exciting to have them use a similar technology and then start this culture of getting credit for things that are three degrees removed from what people cite, because people cite one thing, right? They either cite the protein data bank and forget about every other thing that happens in the middle, or you know, they will cite whatever got published in the most prestigious journal. They will cite the Nature publication, but not the, you know, informatics publication that was the beginning of it. So this allows to credit all along the way. And I'm assuming the question is for me, but let me make sure our panelists here chime in or say, no, I disagree. Because that's when people wake up a little.
Good morning.
Mhm.
Thank you for this oral presentation. I am just wondering how will happen, I mean, what will happen with the novel models that will be developed based on the data set, motivated in this data set as a physician, mathematician, statistician. They will be interested to get those problems in the model that is not still resolved so far in the literature, talking about new models,
Mhm.
novelties.
Right.
So how this will work?
Well, I think the novelty of the models, and again, the models that hopefully are more generalizable, not just for this data sets, right? They would take other data sets and be helpful too. So if we're talking about the predictive models, the AI models that use this particular data, such as we talked about yesterday of transformers and like LLM like models that no longer can be distinguished from the data. I think that that's yet another reason, because every time they get used, whoever's data got into that LLM should be credited to some small degree, right?
Yeah, thank you. But actually, I'm talking about new models, like in general, new formulas, statistical models, new ones. So those were generated based in this motivation of the model of the data set problems.
Mhm.
Normally, when it's new model, it's opened for everybody in different fields, not just in medical situation. It can be engineering and other parts. But it was motivated with these data sets. So how is going to be that in that case?
The motivated, I cannot say, but if there was use of the data, then yes, I can say that it would take credit. It would give credit to the data originator, right? Now, if it was inspired by, but the data were never used, then I can't read minds.
Yeah, thank you.
So let me open to the panel.
Maybe I'll just chime in a little bit on kind of the tracking part, because the previous panel talked about, oh, can you hear me now? All right. The previous panel just talked about an individual's right to their own data and are privileged to use it. And in some ways, this technology kind of provides that linkage. Now, here we started with the notion of the data set being produced by a research group, but what you could track it all the way down to the individual. So the credit system can run all the way down to the individual who provided their data for us to do research on. Again, maybe going back to what Grace asked, how do you envision, perhaps this is a question for us to ponder, is that connected space where data goes all the way down to the individual who produced it being tracked through this system, and in the context of a distributed system, right? This is where the power of blockchain kind of comes in, where we get to see how the same data is used in different models. Because one of the challenges that's coming up in the world of AI is that without this tracking, we don't exactly know what data has been used to build a variety of models. And that leads to all kinds of data leakages that make models more biased than they should be. And are there kind of considerations that we should be thinking about in connecting to the source data and the individuals or groups who have provided them in some way while protecting? I mean, you showed Tim showed some nice access privileges, right? That kind of comes in. So we had a couple of things over the days. So there was Mike Chang's questions. There was the notion of blockchain for consent. And today we're looking at blockchain for data access and reuse. And the final piece is kind of compute coming to the data itself. Because in our case, maybe we don't have as much data. I run a repository with 800 terabytes of data. Distributing that or computing on it is a slightly different ballgame than the current set of data. There are repositories with 5 petabytes of data. There's Filecoin, which is a system that's come online. And I think it's important for us to perhaps look into some of these systems to understand how the dynamics of the systems work in terms of both data generators, data providers, and efficiency providers in terms of compute and analytics on it. But I would love to kind of think a little bit more about credit going all the way back as a personal data store for an individual providing this.
Yep, and there were companies created based on the data donation with some reward back. I would say so far haven't been successful because the money back has to be so small that no one kind of gets motivated by that. But of course, it was large scale, and if we knew everywhere our data are being used, maybe it would pile up and become something sizable. The other thing that was a little against my expectation years ago, we asked, we did a survey what people like, that doesn't like about controlling their own data. As instead of doing tiers, you would have a personal preference. I want to share this, but not this. And that data would still be useful for a lot of research. So things that people didn't want to share was income, for example. And many research does not involve income. So instead of the current all or nothing, share my data or don't share my data, you would have control over that. So we did that experiment, we implemented in another institution. And then we also asked, would you like to know every time someone accesses your data? And I was sure it would say, of course, yes, we want to know. I said, heck no. You know, give us a portal so that we can go look if we're interested. But no, I don't want to be bothered by this kind of thing. So what we noticed too is a lot of confidence in the institution, in the healthcare institution that is handling those data. So yeah, I trust you to figure out when it's good, when it's not, and so on. So I think, of course, these things change over time, but it's very important to to understand. And as we discussed yesterday, some groups, the individual control is not desirable. It's a group control that is more typical. So lots of different ways of seeing this. Yeah.
Yeah, I just wanted to reiterate what the last panelist said about individuals receiving pieces of the profit. The example is the HeLa cells and the family, others making millions of dollars and the family getting zero, communities as well. So really just rethinking that as a possibility, I think is very important.
Well, and I think it is because as before, the excuse was, oh, it's impractical to follow and know whoever used it. It's not impractical. It's just, takes some work to get the infrastructure going. But as we can tell, it technically is doable.
I wanted to address the model situation of the previous audience member. So I think we're just in like strange philosophical waters, right? The blur between a material resource, a synthetic intellectual entity like AI, and the person that is sort of coaxing that AI into a certain model framework to deliver a conclusion sort of takes all of this intellectual property in a new direction. Like if the machine learning is doing most of the work for you, I think about it as a snowball going down a hill. So gravity is the AI, the snow is the data, and you are at the top of the hill trying to make the snowball get bigger and stop at a certain place and become a certain size. And in that scenario, which of those things is the most responsible for the end product, right? And so this is where a lot of this stuff becomes complicated. So if you're an individual and you're in a database and you're contributing to some sort of conclusion or commercial application, maybe everybody in the data set contributed equally, but we know for certain small populations like island populations, the Amish, Ashkenazi, Native American populations, they have a unique evolutionary history where the thing that happened to them only happened to them. So the most popular example right now are those Pacific Islanders that can hold their breath for over 10 minutes while they're diving. That doesn't exist in anybody else. So any model based on those folks, whether it's an epistatic model or an epigenetic model, is mostly contributed, or the intellectual property is mostly contributed by the data, not the person that developed the model.
Well, and then when we had a lot of interactions in the past with the patient center groups, there was some on some areas a desire to say, well, our data is more rare than your data, therefore it's more valuable. So you can think about this both ways, right? So I think as long as we start the discussion and we show the same thing as privacy, let's not use the privacy or the lack of technology as an excuse not to address the problem, you know, directly, and say, well, what is right to do, what's not right to do. Barbara talked about this duty of the data steward that will change. Now, consent is not the only thing anymore. You can't hide behind consent and say, well, therefore it's okay to share. But we know there are commercial EHR data sets available, just a matter of having the money to buy them, right? So lots of things happening, and I think our small contribution here is just to say technically this is doable. Now how to organize ourselves around that structure, then Michael Chang was saying we want promotions based on this. That will take some thinking. So with that, I would like to thank the panelists, and we can take a little break. Sounds good.